Microphone was muted. Okay. What's up, guys? It's Alex from Alexander Design, and yeah, tonight we're gonna be trying something different. Usually I just live stream games and stuff like that, but I'm gonna be running a test for a new video segment I'm gonna be trying to do on my YouTube channel. Yeah, we're gonna be streaming the design process for this fixture. I have to make it work, and shouldn't take that long, less than an hour. And so I was like, you know what, let me try to run a test using SolidWorks and see if I can record something other than a game. So as you can see right here, I have SolidWorks 2014. It's the last time I updated it. I think before that I had 2011, but been using it since release 2005. So I've been using it for like over 10 years now. Take a drink right there, and so yeah, I have a plan that I sketched out in front of me, but since it's for work I won't be showing that, but this is just a fixture for one of the sensors we make, so I won't be showing the sensor itself because that's part of the company thing, but this is just a block of aluminium with some holes drilled in it basically, so that should be all set. Shouldn't have any problem with that. So yeah, we're gonna start new parts, and let's get started here. We're gonna save this as not there, documents. What do we want to save this as? I don't know, just work fixture, because so descriptive, I know, but I'll change it to something more interesting later. Alright, so first, remember, even though this is the first time I've actually streamed SolidWorks and made a video about it, I'm not gonna go through the whole process of like how you actually use it. I'm thinking of doing that as a later video series, but we're gonna make this on the top plane. Yeah. So, hey, come on here. Normally, if I had a full idea of what it is going to be, I would start with the actual sketch and then work out with that. But because I'm going to give this to the wherever you want to call it, machining department, tool room, whatever. Our work, we call it mechanization. I'm gonna just start with an actual solid block and just pretend that I'm machining it away just like a normal machinist would. So we're just gonna start off with a block. Actually, I want the center one. Give me the center one. Why are you gonna be like that? Rectangle. Thank you. And we're going to dimension it. We want this to be 4 inches wide by 6 inches. And then how tall is this going to be? This is going to be about 3 inches tall. Extrude. Actually, no, what is it? It is 2.773 is what it actually is. Okay, so we have our block of aluminum right here. Isn't it pretty? You know what? Don't change the background. The background's bothering me. There you go. That's better. There's too much white going on there. Alright, so we got our block of aluminum. Now let's start making our fixture. This is to hold the sensor so that you can put it into like a thermal chamber or do different functional tests to it. So you just basically need something to hold on to it. It's not too complicated. So the first cut is going to be at a slant, 11 degrees. So we're going to make Cuts on that face. And actually we want that. We want a line, and it's gonna go all the way over here. I'm trying to figure out a good place to put this print because it's covering up my keyboard. Okay, so from bottom to here is 11 degrees. And then we're going to go in like that, parallel to perpendicular, I mean, to that line. Oh, just go like that first, and then we're going to make a cut. Is that parallel? No, that's 10 degrees, so we need to go like that. Then straight down from that, parallel to that. Okay, so actually we need one more line. One more line from there. And that one and this one are going to be parallel. And then from here to here, we want to be 10 degrees. As I mentioned, this is going to be a test for other design projects, my own design projects that I'm going to do on my channel. But this is something if it works, I already have it planned out. And normally, I think I would show you the picture of the final design and show you all the plans beforehand, but for this, I'm just gonna go with it for now. You can see how it goes. Basically, it's gonna be like, you know, there's gonna be a cutout here, and the fixture will go like in here. I mean, the sensor, I mean, will be going in here. Alright, so we're going to put that 7, 3, 8. Rotate it that way. That helps more. That way I'm not confusing myself with the angle, because like all the features are going to be parallel to this line, so might as well rotate it so that's on top. Okay, then how long is that? Okay, so from here to there. Nope. Oh, now it's not going to let me. That's annoying. I want it to be parallel to this line. I mean, the dimension, I mean. Well, from here to there. Hey, whatever. 1.48. There. Then from here, oops, where's my dimension? There you go. There is 0.67. You guys can't really tell that much, but all the commands that I'm doing, I actually have them mapped to the right mouse button. So when I right click the mouse button and then move it in a certain direction, I can pick different commands, which is really helpful instead of, you know, having to keep moving my mouse button over to pick stuff. So you just right click and hold, and then, you know, just move the mouse over to the command that you want. So much easier. So anyways, dimension, what else are we missing? We're missing from here to here. Actually, is that what it? No. From this point to there. Come on. You're not gonna give me that? What if I do this to... There we go. That's better. 0.4. Oops. 4. What does that say? 4.35. Move those. I always like to keep my dimensions neat and orderly, so that if you need to, you can just import them to a sketch later. I mean, a drawing. Makes things easier to see. Because otherwise, these things don't really matter that much, they don't show up in the final part, but it's good to keep things organized. Okay, so from... I do this. Nope. Yeah, that's the problem about drawing at an angle like that. None of the dimensions want to snap to this degree. That's annoying. Yes, yes, yes. How can we do this? You know what? Let's do that. And then we're gonna do that dimension minus the overall of 4.34. I did that backwards. 4.134 minus 1.48. Actually, there's an even better way of doing that. Oops. Equals. Oh, that key. What? Fine. Thank you. Equals 4.134 minus that dimension. Come on. Why? Hello? Why didn't that work? Anyway. I was trying to have this one defined on that one so that everything moves accordingly. But it doesn't want to work. I can't do that either. Fine, be that way. I don't think it'll matter that much. I wanted to have it this point defined by that edge right there, so everything's the same. But I don't think it's gonna matter that much because I don't see us ever changing this after the fact. Okay, now what I want is a line from here to, let's say, there, and you want it parallel that. Okay, that's, and you want a dimension that's from here to here. 0.527. Okay, so we're gonna make that our reference line. And we're gonna have to draw another solid line from here to there. So that's that, and I believe that should be it for the top. So now we can convert that entity and then trim it. And that. Oh, I want to convert that one too. And that should give us our profile that we want to cut out for the top of the part. Cut extrude through all. That should cut it off. And bam. Alright. Yeah, like I said, you could start with just that profile and just extrude it out to begin with. But when I'm making things that are going to be like CNC machines like this, I usually like to, like I said, I usually like to start with how they're gonna start, i.e., block of material, cut away the excess, so that usually helps if you're like trying to make something, and then if you're cutting away the material versus adding it, then you're like, oh, you can't actually cut that away like that because it's not physically possible. Always good to keep in mind. Alright, so that's our block. And now to start drilling holes in it. Oh, what else? We also need a slot on the bottom here. So, start a new sketch on that. Hey, where'd you go? Give me a slot. And it's going to be 0.26 high by 0.954. It's actually going to be a range between 0.952 and 954. That's the range they have to hit when they machine it. But for right now, we're just going to go with that because that's something you can specify on the drawing, which I already have. And now we're just going to specify the distance for that. And what we're actually going to do is I want to specify it by the center. So we're going to grab a center line here, there, and dimension to that. And that needs to be exactly 3 inches. Okay, and cut that through all. Thank you. So that's a slot. So this will be the fixture that holds it. The sensor is going to sit in this whole area, and then this is going to mount to the chamber, and this is going to be like an aligning guideway, so this will be easier to place. And now we're going to do the bolting holes. Whoops, hitting my microphone. So where do we want to start? We're going to start here. Going to create a sketch in that plane. View normal to that. And let's make some holes. So we're going to do two sets of guidelines here. Grab the center, and then we're going to say you, and you. Oops, that's not what I wanted. I want this. That one line, and then these 2 points will give me a symmetric constraint. And now they move the same, so that means I only have to dimension it once. From here to here is 1/2 inch. Then for so we're gonna actually do the same thing this way. We're gonna grab, except don't know if it'll let me grab the actual center of this part. Okay, maybe we won't do that. So here, then there. Oops, that's the wrong type of line. This is also going to be 0.5. And then here to here is 0.5. Because remember, the part's at an angle. Actually, I lied. I was looking at the wrong side of the print. I have the print laid out in two ways. One is what the angled top is for easily laying out dimensions here, but these holes are actually going to go straight through this way. So, close that sketch, and we're actually going to create a plane. Parallel to the top, and then... Oops, come back here. It's right there. Alright. Now, what we can do... Put that there, I guess. Edit sketch plane. That should move everything. I'll have to do some adjusting, but... Actually, no, that's not what I want to do. I want to open this sketch back up. And... Oops. That way, please. Which is actually the same as the top, but I wanted it not at the bottom of the part. And... yeah. So we're actually going to have to delete that. Because I want it that way. Point 5. 0.5. Okay, so that should give, so these will be the center points for our mounting bolts, bolt holes. I think that's all we need for that, right? Yeah. So these are going to be counterbore holes, and we could do them manually, but what I'm actually going to do, I'm just going to put a point right there. Come on, give me the intersection of those 2 points. So we're going to put a point there, and I could just draw a circle and, you know, cut extrude it out that way, but we're actually going to use the hole wizard, because it's a lot easier. Hole wizard. And these are going to be 1/4 socket head cap screws. Counterboard. Want socket head cap screw, size 1/4, fit normal. Yep. Alright, so positioning is going to be there. Select the face, so that's there, 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 and there. Okay. However, These are going to be counterbored really deep. So we don't use like mile-long bolts because it's going to mate to this face, so they are all I forget how to change the setting for that. This doesn't really matter because I'm just gonna go through all. Where's counterboard depth? Oh. So the easiest thing to do is a 1/4 inch from the bottom of that, but I don't know if we can do that using the hole wizard. So how tall do we say this is? 2.7. So since this plane is the top of the block, I mean at the height of the top of the block, we're gonna go the height of the block 2.773 minus what did we say it was? No, that's not what we want. Oops. Bring up my calculator for a second. Yes, you know. Bring up my... Actually, no. That will work. Think. Right? Should work. Maybe. Does this not accept equations? Doesn't seem like it wants to... Hey, come on. I know in dimensions you can do math, but in this one, doesn't seem like it likes that. So, let's bring up the calculator here, which I don't think is going to show up on the stream, but anyway. 2.773 minus 0.25. 2.523. There we go. Much better. So that'll be counterboard. And just to check, we can measure it from the counterboard face to that face is indeed 1/4 inch. Brilliant. Okay, so we don't need that sketch anymore. Hide that. Okay, so that'll be our mounting holes. Ignore that for a second because we're gonna get rid of that. Okay. So those are the 4 mounting holes. And now we're going to we have to machine a pocket in this face right here for one of the protrusions that stick out of the sensor. This little part that like sticks out, and the rest of it's going to need to sit flush. So actually we can hide this for right now, and that one's going to be parallel to this face. We're going to create a sketch right on this face. It's going to be in the center, so we can actually just make center line here, and we're going to set a rectangle. And this cutout. This is basically going to be a rectangle with a little slot cut in it on the side. How big is this? Alright. I forgot that this is actually specified by this corner right here. There's a 0, 0 point, and then everything is off of that. So we're actually not going to do that. We're going to do... Oops, no, this. We're going to do horizontal ordinate dimensions. So that's 0. And okay. So I'm going to make this a little bit differently than how it would actually be machined, because obviously when you're machining something, you have an end mill, and the end mill is round. So dimensions of that be from the center point of the end mill. So I'm going to do that first, and then we'll round it out. You might be confused for that with that statement, but you'll see in a second. So we're going to go here to there. And that is 4.285. So this will be the center of the end mill, and obviously it would come out like that. But I looked at the wrong one. This 4.810 is that one. And then may have canceled that operation by accident. I don't use this function that much, so I forgot. No, give me that. Forgot that you actually have to place all your dimensions first and then go back and edit it, unlike on the smart dimension. Typically use smart dimension for everything and only use the ordered dimensions on prints, but that's how it was specified, so I have to do that. Alright, is there anything else? Yeah, so that's that. You want to do so. This is the 4.81. Yes, so that's good. We want this to be 5.8. Oh, I forgot about that slot. What do I want? I want a center point slot. No. Is it? Yeah. Well, I do want that, but that's not where I wanted to place that. There. Give me... Okay. And vertical ordinate dimension. That's going to be 0. We need... This should be in the center, but I'm going to dimension it anyway. Just 'cause I want to make sure. It's not actually in the center, I lied. Should have known that beforehand, because duh, 2 inches is half of 4, and it needs to actually be 1.937, so it's almost in the middle, but not quite. So we're gonna get rid of that point. Need to get rid of that too. Because okay, let's try that again. Here to that line. Oh, I forgot a point over there. Leave this dimension driving because I'm gonna get rid of this point. There we go. Damn it, I canceled out of the command again. Hey, ordinate dimensions. So annoying. Except when you're actually machining something. Then they're useful. Oh. But other than that. So that's that. Is that it? Is this not a square? This might not actually be a square after all that. Arg. Alright. Backtracking. Get rid of those. Because doesn't appear to be actually a square. I made a mistake. Or maybe this will be okay. 1 point. And by a square I mean rectangle. I don't know what I was saying. Because squares and rectangles are totally the same thing. They are quadrilaterals. Anyway. So that's that. And then we want 2.218. Just check. From here to there. 1.656. Yes, it is. Now that I erase that. Do this for a third time. Because efficiency. Alright. That point. That point. That point. Okay, just consulting the plans here. Okay. We got this one. 4.285. This one is that. This one is 5.8. You can be coincident with that point, just not in the center. This radius of 0.125 because it's going to be an 1/8 inch end mill. Alright, so these are actually going to be all construction lines because those are just the center of my points. And need 4 circles. All equal to each other. And we're going to connect all those circles to make the pocket. Oops, that's not what I wanted to do. Get rid of the extra here. Oops. Before I do that. You are not a diameter. You are a radius. radius of 1/8. Alright, now I can get rid of the extra stuff. You. Hold on. SolidWorks, if you go get rid of circle segments out of order, SolidWorks yells at you. This is going to explode that, but it's okay, we don't need it. Actually, trim this too. Symmetric. Why are you still... That... No? It's still out of place here. Oh, that. Because I got rid of the slot thing. So you are horizontal. Oh, yeah, that's all you needed. Alright, what is this? What are you? You are not a thing. Why are you there? Alright, so that's our pocket. I admit it may not have been the most efficient way to do that, but like I said, I'm doing this on the fly, so it's whatever comes to my mind first. So we're gonna cut extrude that 3/4 of an inch. 0.75. Oops. There's our pocket. Look how beautiful it is. So, bolt holes and mount the fixture to the chamber. We got the pocket for the thing, and now for the mounting holes for the sensor itself. We're going to put 2 holes here on that face, and we're going to do the same hole wizard as before. Nope, not in the center. You. What? Why you do? From there to there. And you are... You are 0.355. From there. And because I'm using the hole wizard, I don't actually need to make circles once again, so... Hey, give me that. 1 there. 1 there. And... we want vertical thing because easy for machinists there and there. 1.437. This one is 2.437. And these are actually going to be drill and tapped for a 1/4-20 bolts. Or socket head cap screws actually. So we're gonna do that. Let's close that first. Hole wizard. These are not going to be countersinked though. I just want a straight tap. And where is it? There it is. 1/4-20. This is not going to be through a hole. This is going to be blind. 3/4 of an inch. Quarters of an inch. Right? Yes. That face. Right there. Right there. And that should be all set for that. Okay. Hide that sketch. Cut that one, and then we're gonna have one more hole right there. It's just gonna actually we can do that right in. It's just gonna be a single point, so get rid of that and do that right inside here. You want that. Then vertical. Actually, I didn't really need to do that for only one dimension, but whatevs. 0.807. .165. Alright. That's that. Reset everything. Yes, yes, yes. Alright. We're good. You know what I wanted to do with that? That. Alright. So we got those holes. Let's see, I'm looking at my print here. Check, 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 check. Check, check. Alright, almost done. And so the last thing we need to do is see this right here. We're gonna get rid of that because we don't need that material. So all this material like up in here, we don't need any of that. So we're gonna get rid of it. So put a sketch here. And actually, you know what? Where is my origin? I put it. Why did I do that? Usually I put the origin in the center part so that when you have the, you know, the front and right planes, it should come in the middle. Actually, what? Oh, because I'm in a sketch that moves the origin. That's why. Right? Or never mind. I did it correctly. So we're actually gonna grab the front plane here, so it'll be in the center of the part. And so we're gonna grab actually, let me think this through. Do we want it in the center? Because I need to cut it on this side in and then that side in. So I could put it on this plane, cut it, and then mirror it over. But then I would need to... No, we can still do it this way. So, do that. And we want to grab this line, that line, yeah, that's all I need. Convert those. And we're gonna go line straight across here to about here, and then go down like that. Then go here. then extend that line. Brilliant. Okay. This is going to be here to there. It's going to be 0.76. From here to here is 0.34. And then that way is 2¼ inches. Okay, so we got that. Now, get rid of that. Get rid of that. And that'll be it for our sketch. And then what we're going to do is, do I need to make another sketch? Actually, I think what we can do is grab that. I think what I can do, actually, direction 1, offset from surface, that way. We want to offset it 1/2 inch, so it's going to be even with this. Whoops, even with the center of that hole. I think that's what I want, right? Offset from surface. Half an inch. It's not showing up though, which kind of makes me wonder. Is that gonna work? No. Okay, what am I doing wrong here? It should work, right? I want to say I want to off from this side and cut that way. But okay, that's that. Oh, I think I did. No, I did. That. Yes. Nope, that's not what I wanted. Oh. I think it's still gonna pull from this plane anyway. So yeah, so what we want to do is that, but instead of from the sketch plane, we're gonna offset it 2 inches? There we go. That's what we want to do. Just mental gymnastics there, figuring out. So basically what I told it to do is, here's the sketch plane, but I want to go from this face inward 1/2 inch. Yes. Now if I do a direction 2, it's going to go from that plane, right? I don't think it's gonna work this way. Because it's gonna be offset from that plane. Yeah, we can't do that. Alright, so we'll just do that one. That's what it's gonna look like. Perfect. Then what we can do is take that again and do the same thing, only on the other side. We could mirror this feature over, but it's always better to have this instead. So we're gonna do the same thing, offset 2 inches, but the other way, and then oh, why aren't you rotating? Oh. Yes, that is what we want. That should be 0.5, yep. Brilliant. Alright, so that's our fixture. Actually, that's still there. Why is that still there? That wasn't there in the original part. I do have one of these things already machined, but I need more of them, but we don't have a 3D model, so that's why I'm making this right now. And this doesn't have that there, so what did we do wrong? Huh. Maybe they just like cut that off. I followed all the dimensions. Dimensions are correct. These, right? These should be 1/2 an inch from here. Yep. And should be 1/2 an inch from here too. Yep. So that's correctly positioned. Huh. Everything else looks good. I don't know what's going on here. So we'll make a quick fix. Actually, no, I don't want that. You. What? Oh. Grab this plane. That's what I want. There you go. And we're going to grab the center of that circle. Go here. Arbitrary amount, doesn't really matter. Call it 0.5, and center line, mirror that over. Yes. Okay. Now cut up to next. No, that's not what I want. Up to surface. Ta-da! Actually, do we want it like that? No, that's gonna be cause problems when you machine it. So where is that? What we will do see that point. I'm gonna convert. I forget, can you convert a point? I don't think you can. How about that? Yeah, you can grab that. think we only need to, yeah. Alright, so we're only gonna go up to there. Make that coincident with this. Nope, coincident. Trim that. Oops. Yes. I just have to fix that. That should be better. Get rid of that. Easier just to mirror back over again. You mirror there. Okay, now do that. There we go. Still looks weird, but I think that'd be better because if you're looking down from the top, they can just have the end mill here and then just go that way. I think that should be good. Alright, so got the majority of that all set. Actually, are we done? I think we might be done. So we'll save that. I should have been saving it more, but it's always good to save like every 10 or 20 minutes in case something happens and you lose all your work, but distracted by the stream here. I think that's all we need. We got holes for mounting, holes for things like that. Yeah, I think that's it. So we got our fixture here. This will be sent to our machine shop here. Is called mechanization. So like I said, I have a print that I made up, but because it's going to be CNC'd, they needed a 3D model too. So decided to quickly make the model here. It only took us what, like an hour? I forget what time I started this at. Less than an hour. 3D model. So good. I don't know why I just saved that again, but so that's about it. Thanks guys for watching. Like I said, I plan to do more of these in the future, more SolidWorks live streams in the future. Well, probably not so much live streams, but like definitely YouTube videos, and I'm probably going to export this to a YouTube video afterwards. But yeah, I'm definitely looking to do more design stuff in the future, like coming up with cool little designs of my own and then making them in SolidWorks. I have a 3D printer, and so we'll be doing work with that as well. So like make a thing and then send it out to the 3D printer, do a cool model like that, and should be all good. So thanks for watching. Stay tuned for more SolidWorks and design videos in the future, and that'll be it. I think I'm actually right now going to be playing some of the new raids in the Destiny for Xbox, the Xbox version. So if you would like to join us for some Destiny raid action, feel free to stay tuned. That'll be probably starting in a few minutes. But if you're only interested in engineering designs, keep on the lookout for more SolidWorks models. So thanks for watching, and we'll see you next time.